All right. Hello, everyone. Thank you for joining today's webinar on backup and disaster recovery. I'm Toji George. I'm a solutions architect with MongoDB. I work with our customers and our sales teams to work with customers, understand their requirements, and work on helping them solve problems with MongoDB, figure whether MongoDB is the right fit or not. So that's my role. Today, we will talk of the requirements around availability and backup, talk about MongoDB solutions in that space, and focus a bit more on backup tools from MongoDB. If you have questions as I speak, you could use the chat function in this webinar to put them there. Towards the end, I will address as much as I can, depending on the time and what I know. So for this talk, I'm going to assume that you know about MongoDB. There are several good webinars and presentations that are available on the topic at our website at mongodb.com/presentations. So this isn't meant to introduce MongoDB, but talk more about cases around availability and backup. So your applications have to meet several requirements, right? And there are various tools and features within MongoDB to help that. Now, some of the requirements could be along the lines of those you hear here. That's expressed here on the slide, or some variant of it. You need your applications to be able to access the data in the event of, say, server or network or memory failures, or even if one of your data centers is offline, you need your applications to continue working with maybe another data center that you have. You need to know, for example, how many copies of your data definitely exist and in various places. Or maybe some error happened yesterday that modified your data, and you want to get back to a point as close to that as possible. Well, in short, I'd say that these requirements, the ones that I'm focusing on, not all the business requirements, but these ones, you could say that they are around availability, and there are requirements like the one going back to an older version of data that would relate to backup. Now, the thing with these requirements or trying to fulfill them is the amount of effort that you have to put in, and indeed the cost around addressing the requirements and the infrastructure you put in for that. That's driven by your business requirements, right? So two of the numbers that you would use to express these are RPO and RTO, the recovery point objective and the recovery time objective. There's good, long, exhaustive definitions of these if you just Google them. But simply put, RPO would let you determine how much data your business can afford to lose in the event of a failure, depending on what that application or what function for business that's fulfilling. That could be in minutes. It may be longer or it may be shorter. For critical systems, that value could be 0. And RTO, that lets you figure out how long you have before you can bring that data back online for the applications. Or indeed, the application can be brought back online. So these are the ones that you try to meet, and we'll talk about how MongoDB can help achieve the goals that you have around those. So let's discuss solutions around availability. So in MongoDB, replication is what we use to provide redundancy and increase the availability of data, right? Replication helps you create multiple copies of data. We call these copies as replica sets, and you automatically synchronize changes that you make to the primary copy of the data to other members of the replica set. That's called secondaries, right? So MongoDB, to do that, MongoDB uses a cabbed collection in it's called oplog, that stores the ordered history of all the writes that's happening to the database, and it can idempotently apply that to the secondaries so that you have a synchronized copy there. So when a primary fails, MongoDB automatically chooses an appropriate secondary, there's an election, and chooses the secondary that has the latest data to take over as the new primary and automatically fails over to it. Now, the drivers that your application use to connect to the database, they are aware of this topology, and thus your application, when it makes connections, it will, and when it tries to write, it will always write to the primary. So the time that it takes to fail over, that tends to be in seconds, and for failures that cause a primary to be unavailable, your RTO, therefore, is in seconds, right? So depending on your application, you may choose to read from the primary that has the latest changes, or maybe it's acceptable to have eventually consistent data reads from your secondaries. So based on the preference that you have for your reads, you could even have a continuously available application from a read perspective. Of course, how many failures you can tolerate, that will depend on how many members you have in a replica set. So say if you have a 3-member replica set, 1 primary, 2 secondaries, that can cover you for a server being unavailable, right? 5-member replica set, that can cover you with, you can continue normal operations even if 2 servers are unavailable to the application, and so on. So due to workload or data size, right? I mean, you may deploy MongoDB as sharded clusters where you have distributed data across different shards. Well, each shard can, and I should say should, be set up as replica sets so that you are able to meet availability requirements you have. Now, these replica sets, they can span servers or racks, or it can be across data centers, right? So you can deploy replica sets across multiple data centers so that it stays available even if, say, all members of replica set in one data center is not available to your application. So there are times when you have to account for planned downtimes, like you may want to do database upgrade or OS upgrades or swapping out disks, things like that. Now, with a replicated MongoDB setup, it's possible to do this in a rolling fashion so that availability to your application is not impacted. So replication helps you not just cover with the failures around infrastructure, but also keep your application available during these planned changes or planned downtime operations. Your application, of course, can decide how durable the data should be, right? So depending on your business's RPO requirements, your application may want that data be acknowledged as written, not just from the primary, but from at least one other server, maybe a secondary, another data center, right? So the applications can do that because let's say you write to a primary and there is a network latency before the data hits the secondary and is written there. If a primary fails, there is that few seconds of data that can be lost. Now, if you want to protect against that loss, it is possible to do that. So for that, you use something called write concerns. So let's say a write concern of 2, as defined by the application. When it does the write, that will write data to a primary and at least one other secondary. Or you can use the write concern of majority so that you know that at least a majority members of the replica set have the data before it's acknowledged to the application, to the client. So application can get acknowledgement after the data is written to whatever you specify as the write concern. You could also use something called replica set tags and use that as a write concern. Maybe that tag could specify that I have some members in a primary data center and at least some member in the secondary data center. That's part of the tag into which, or group into which the data is written before you acknowledge back to the application. Now, these choices, of course, are driven by availability requirements, right? Your RPO. There is a trade-off in write latency. So if you insist that write be acknowledged by one other member, especially if that other member is in a different data center. So that's how the replication can help meet your RPO objective. So There's a question here about how is data replicated from a secondary to the other copies, meaning when a secondary has to take over after a primary failure. So when a secondary takes over after a primary failure, it becomes the primary, and then the other members become the secondary. And the same mechanism or offload mechanism that we are using, and that's used, and the other primaries keep up with other secondaries keep up with changes that are happening to the primary using offloads. Now, replica set, I spoke about replica set being the way for availability. Now the choice, of course, is in how you deploy that to meet your objectives. So you can have primary and multiple secondaries in the replica set, and this picture here shows a deployment that's specific to maybe one data center, right? So the column here is, think of them as physical racks, or if you are in Amazon on AWS or something, in a single region, you can think of these columns as availability zones within that region. So this sort of deployment would give you a tolerance for server failures and for rack failures. I've already talked about the fact that the number of members in the replica set determine how many failures you can tolerate. So you got to adjust according to that. Now, but then what about disaster scenarios, right, where you need data to span multiple data centers? Well, this figure here illustrates one such example. Right? So, and there are many ways to skin this to do this. And here we show a setup where primaries are in the west. By the way, if your application requires and with a sharded cluster, you could have scenarios where you are doing writes to different shards with some primaries located in the east and some in the west. And we got webinars on sharding that will talk to you in a lot more detail about that. For now, let's just take this example where we're trying to do a primary, secondary kind of, or a main data center and a second data center kind of scenario. So with primary in one and secondary in one data center, you can tolerate rack and data center failures, right? So there is local availability through a local secondary, and then of course there are remote secondaries available here. You know that in this topology there is I've shown a special type of replica set member that's called arbiter. Arbiters don't have any data. They participate in election for a new primary. So in this scenario, if let's say a network partition causes the entire west to be unavailable, arbiters can help secondaries in the east to establish a majority and elect a member, elect a secondary, let's say this guy to be a primary, for the replica set A, and so on, right? Now, there's a question here about does a new primary get demoted back to secondary when the previous down primary comes back online, or does it stay the primary? To watch it, the mechanics of replication and all, I totally recommend going into a webinar that talks into a lot more detail about it. But the answer to your question is, by default, each member of a replica set is treated as equals, right? So if another guy becomes a primary, it stays the primary. But if you want that specific members of the replica set, let's say this topology that you have on the screen, you want that the members in the east or in the west become primary as soon as they are available, you can set something known as priorities for these replica set members. And let's say you set this primary A with a priority of 2 and others have a priority of 1. When this primary is again available, it will force an election, and then when everybody votes, they realize that this member has a higher priority, and that becomes the primary again. So it is possible for you to force that, but if your application is able to talk to any of the members in a replica set, then it's probably simpler to leave them as a priority 1, again, determined by how you want to do this. So the thing is, you can use replication to keep your MongoDB database available, right, for your applications. It's built into MongoDB. You do not have to install or maintain or manage any other software to make it possible. So you can meet your RPO goals, make sure data is written on one node, two node, or majority of your replica set members, and your recovery time objective in the event of failures, whether it's server, rack, or data center, it's typically in seconds, driven chiefly by your workload and network latencies, right? And the thing is, for these failovers, there is no need of manual intervention to deal with this. It's all done based on your configuration. A quick question here is, how can we have stretched replica between data centers? So that was what I was showing in the previous diagram. In this case, look at the green ones that's shown as replica set for let's say shard A. So the short answer is yes. You can have replica sets going across data centers. So that was availability. Now let me talk about backup. And I think at some level, most everyone understands the need for backup, right? But then there is always a bit of a lax attitude to it. It's something you do later. And specifically, if you have a database like MongoDB, I've heard people say that, hey, there are all these copies we have via our replica sets, so why bother with backups? Well, I'll put a link here to an earlier presentation that talks about good business reasons why you should back up. And I believe you will get a copy of these presentations later from our site. Technically, these replica sets, of course, are copies, yes, but they are the copies of the current state of data. So if you need to go back to a previous state of data, maybe because some admin accidentally dropped a collection, or maybe some changes were rolled out in application that changed the data in ways you did not want it to change, you will need to get back to it, and that's where a backup comes in, right? So for MongoDB, there are manual and automated ways in which you can do backup. So for manual methods, you could do with tools that come with MongoDB, like MongoDump and MongoRestore, or there are external methods of backing up at the storage level. And then also we provide automated ways of backing up with our MongoDB Management Service, or MMS, and or Ops Manager. So let's talk about each of them. So MongoDump is a tool that can read data from MongoDB database and then puts the data out into like high fidelity BSON files, right? And MongoDB Restore or MongoRestore tool that can use those BSON files and then use that to populate a MongoDB database with the data that you have in it. So MongoDB dumps out data only. So the file output will be smaller than the database, but on the flip side, when you restore, your indexes have to be recreated. You can take MongoDump with the oplog flag, and that also creates oplog BSON output file at the top level of the directory you're outputting to. It contains oplog entries that occur during the MongoDump operation, so that way this file can help you provide an effective point-in-time snapshot of the state of that MongoDB instance, right? Without that flag, if there are write operations during the MongoDump operation, your output will not reflect a single point in time. Now, there are additional capabilities. You can filter specific databases out or collections out, or maybe you could pass a query as a JSON, and your output would be limited to what you back up. The backup would have the response to what those queries are. Now, these tools are simple. I mean, they're efficient for backing up small MongoDB deployment, but they're not really ideal for capturing backups of much larger systems. You can imagine it will be slow, and it can take time to dump out the data. It can contend with existing workload, but for that you can, of course, run it against a secondary. Now, In a sharded cluster, the oplog flag is not useful when you try to run it against the MongoS router. So you can run against an individual shard, but then that can have other problems in attempting to take a cluster-wide consistent backup. If you're familiar with sharding, you know that there can be balancing going on of data, and so you have to do steps to make sure, and it's not impossible, it's just a bit difficult on how you can synchronize and get cluster-wide point-in-time backup. I see there are some questions. Some of them are on replication, which I'll take later towards the end. One question is, can MongoDB be configured via cron jobs? Well, you can invoke it from the command line. So I think, yeah. And if a backup one question is, if a backup was taken using a prior version of MongoDB and was needed for recovery, perhaps a legal research issue, and are subsequently upgraded to higher version of MongoDB, is there any recovery issues to be aware of? It really depends on some versions. For example, later ones cannot go back to before 2.2. I think there are some things like that. But then, of course, you could restore it back to those previous binaries. So I'd say that it really depends on the version and the version you need to go back to. We just have to see what steps you need to do to be able to restore to that old version. Now, there was another question, can you perform Mongo restore live? Well, you can, except it will, if there is IDs, document IDs that exist, it will not overwrite. So you have to be selective about what you're doing there, right? And it is possible to do that, but I don't think, if we talk about the scenario of the backup and restores that we are talking about, that may not always be the right thing to do. So talking about storage level backup, the other manual method is to take backup at the storage level, right? So you can create a backup by copying MongoDB's underlying data files. Now, if the volume where you put the MongoDB data files, if they support point-in-time snapshots, then you can use those snapshots and create backup to an exact point in time. For example, the EBS storage volumes in Amazon, they have support for snapshots for the EC2. On Linux, if you're using the LVM manager, that can create a snapshot. So basically, the method that you may use for a storage system snapshot, that will be dependent on the storage system and your system. These are not MongoDB features. It's something you figure out based on what you have to work with. But yeah, they are fast, right? So if you're planning to use these, you need to put some careful thought again into how to make sure you get consistent snapshots. You have to make sure that the database is valid when the snapshot takes place. So to get a correct snapshot of a running MongoDB process, you must have journaling enabled, right? And journal must reside, it should reside in the same logical volume as the other MongoDB data files, right? Now, if you have a sharded cluster, to get a consistent snapshot, you must disable the balancer and then capture a snapshot from every shard and config servers at about the same time. Now, remember, these snapshots create an image of the entire disk. So if you use this method, you may want to isolate MongoDB files and not put other stuff in there. That's basically part of the storage planning. So if you need to think through where the snapshots go, right? So typically that will call for ops to work with the DB team and basically systems and storage team may have to work together to make sure that the right playbook, depending on your environment, is created and tested. right? So backups that are produced by copying underlying data, they do not support point-in-time recovery for replica sets, and they can be difficult to manage for larger clusters. Additionally, the backups are larger because it will include everything, data, indexes, and everything in comparison to MongoDB, which will have smaller backups, but again, they are slower than the storage methods. Now, moving to the automated methods, here you have a choice, right? You could back your data to MongoDB Management Service, MMS, that runs on the cloud, or you may have reasons like my data cannot leave my data center, or maybe because of regulations or something like that. There you can use Ops Manager, and Ops Manager is something you get with the Enterprise Advanced License of MongoDB, and you can use that to deploy Ops Manager to your own cloud, whether like AWS or in your data center or in your colo. So both MMS and Ops Manager that provide ability to automate the deployment of your clusters and manage changes to it, automate upgrades, and so on. They provide ability to monitor your cluster, view metrics, create alerts, and of course, to the subject of our discussion, they let you take backups with ability to do point-in-time restores. For sharded clusters, there is support to get consistent restores too. I've put some links here in the presentation. You may want to check that out to know what is MMS or Ops Manager overall at a high level, to see more about monitoring and automation. We will focus on the backup aspect of it, right? So with MMS, your MMS, and just to start using this, you know that with MMS, the infrastructure is already there. But with Ops Manager, if you're starting out, you have to set this up in your data center, right? So the part about the application and a database that has the metadata to support the UI and various jobs and all that, that part is simple. But there is the actual infrastructure for keeping the backups. Right? It's critical that the backup infrastructure is sized correctly to meet your needs. You may, depending on how many shards you have, how much data you have in one or more of your MongoDB clusters, this backup deployment needs to be sized correctly. It will also depend on the workload you have. So you may have availability requirements for the backup infrastructure too, and that needs to be taken into account. So if you're using Ops Manager to gain this advantage of being able to recover data to specific points in time or get consistent sharded cluster-wide restores, you will have this upfront work of setting the infrastructure for it. Now, since you get this with Enterprise Advanced, you have support, so we strongly recommend that you work with us to size that backup infrastructure out correctly. Now, once set up, it's easy to use, right? With MMS or Ops Manager, the steps are pretty much similar after that. You make sure your cluster is monitored by the tool, and then you may, of course, choose the tool to manage the deployment for you. And from a backup standpoint, you just start taking backups. Now, I'll talk through how it works in a bit, but before that, let's do a quick comparison of this various approaches, right? So MongoDump can be a little difficult to set up in terms of getting consistent backup or figuring out how to use with sharded clusters and be consistent, where to place files. I mean, these are small deployments. It's easy enough. It becomes difficult as the deployments or more than one deployments grow. MMS is, of course, there and ready to use. Now, the file system and Ops Manager, that will involve some upfront effort to get started. I would say ops teams who have experience with other systems, they would not really call the process difficult, but if you're not doing it already, there is, of course, a learning curve to understand what you're doing and why. I think I've talked through some of these points already. Generally, if you need to take consistent snapshots, especially for sharded clusters, and be able to restore to points in time, it is way easier to meet those objectives with MMS and Ops Manager. The MMS and Ops Manager that takes initial sync of the data and then keeps getting changes that are coming from the op log, right? An op log, as I mentioned earlier, is something that helps with replication, and we use that same mechanism to keep getting changes from the source databases. So that means you cannot use MMS or Ops Manager with standalone MongoDB. They have to run as replica sets or as replica sets within sharded clusters. So now from a restore perspective, to meet your RTO needs, I'd say file system snapshot methods are fast. Once you have figured it out and set it correctly, the Mongo restore is a lot slower. With MMS or Ops Manager, you get your data files, and there is that time to get that files, and then you copy it over the network and do the restore-related work. So in a sharded cluster, that could mean doing multiple operations, and hence I'd say it takes a longer time than file system snapshot restores. Now, once you decide to use Ops Manager or MMS, you start your backup. You would decide your retention schedule, how long you want to keep these backups. I mean, these tools will take periodic snapshot of your data, and by default, that's every 6 hours, while it keeps getting changes from your database's op logs, right? So you can keep these snapshots for up to 5 days. In addition, there are daily, weekly snapshots that can be kept up to a year, or monthly snapshots that can be kept for 3 years. So you may choose to exclude, if you want, certain namespaces like database or collection from the database, from the backup, which of course means that they will not be available for restore. Right? So let me show you the UI from an MMS perspective. I'll just share this. Hopefully you can see my MMS screen here. This is a demo environment. I've just created a sharded cluster here and a replica set using on 4 nodes that I have on AWS. So this is the MMS, and this is the deployment screen. I don't intend to demo too much here. Basically, this is where you could use to add or create new clusters or replica sets. I can provision machines and so on, but that's part of the automation functionality. Let's talk about backup. And again, I'd encourage you to look at the other webinars I have mentioned earlier that talks about automation, about monitoring, and things like that. Here we'll focus on backup, right? So here I have, you see that the cluster itself is being backed up. The replica set, I have not started a backup there yet. I can, of course, configure my different options that I need for the replica set. I can view the different snapshots that are taken. The edit snapshot schedule would let you configure how frequently you want the snapshots taken, how long do you want it saved. In case of with replica set, you can get point-in-time restore, right? But if you have a sharded cluster, you can create checkpoints to provide additional restore points between snapshots, right? So with checkpoints enabled, Ops Manager Backup can create restore points at configurable intervals. That's like 15 minutes, 30 minutes, or 60 minutes between the snapshots. So to create a checkpoint, what happens is when you want to back up your infrastructure, there are backup agents that's deployed, and those agents will stop the balancer, that they'll insert a token into the op log of each shard and config server in the cluster, and that's how you get. That's how we are able to create these checkpoint restores. So that's how this works. And let me here I can start the backup for a replica set. Maybe again, when I want to start it for a deployment that's not already backed up, I can say where I should sync my data from. I choose to do it from any secondary, and then there are some advanced settings if I need to, and I just start the backup. And the initial backup and the initial sync and all that takes some time. So that brings us to the topic of how this works. So let me get back to my presentation here. So how this works is you start with your production deployment, right? You have replica sets or sharded clusters. So when you start your backup, we take an initial sync of the data and we start tailing the op logs. Now, the bottom area here, that's something that's transparent to you if you are using MMS, but the scenario is pretty much the common for MMS and Ops Manager. So when you start a backup for MongoDB deployment, and the backup agent that would be here, that's part of your deployment, that would perform the initial sync of data as to here as if there were a hidden new member of the replica set, right? And for a sharded cluster, the agent performs a sync of each shard's primary and each config server, right? So the agent ships the initial sync and oplog data over the HTTPS back to the Ops Manager. The backup agent then tails the replica set's oplog to maintain an on-disk standalone database that those are these heads. And for each backed up replica set, right, each head is consistent with the original primary up to whatever the last oplog was supplied by the agent. Now, the backup daemon that's here, that manages all the local copies of the backup database, as well as backup snapshots. So backup will take scheduled snapshots and store these snapshots in these backup block store databases. Those are MongoDB databases. It makes sure that consistent snapshots are stored for the sharded clusters, and then you can have multiple backup daemons to increase storage for backup. That way you can scale horizontally using multiple backup daemons, and that can also provide a manual method of failover for the backup infrastructure if there is a need for HA of the backup infrastructure. Now, the backup block store databases, they are the MongoDB databases that contain these snapshots of the databases that are backed up, as well as oplogs that are retained to be able to do point-in-time restores. Right, so you should configure these block stores as replica sets for high availability first. Now, internally, we use compression, we use block-level deduplication technologies, and that helps reduce the snapshot data size. Right, so the snapshot only stores the difference between successive snapshots. So they use only a fraction of the disk space in comparison to full snapshots. So it's so that therefore, if you have a large enough database here, that doesn't mean you're depending on the number of snapshots. This backup infrastructure is not a multiple of that number. It's a few multiples of that number. I think 3 to 4 times larger. Now, the daemon will also act on restore request by retrieving data from the block store and delivering it to the requested destination. So what happens is MMS, as well as Ops Manager backup, that lets you restore data from scheduled snapshots, right? Or you can create a selected point in time in between those snapshots. So for sharded clusters, you would select, you can restore from a checkpoint in between the snapshots. For replica sets, it can be selected point in times based on the oplog changes that are coming in. So when you restore from a snapshot, MMS or Ops Manager will read directly from the backup block store database. You can transfer files, and then once you get those restore files, you can transfer files either through HTTPS download link, or you can send them via SCP. Now, when you restore from checkpoints or points in time instead of the snapshot, Ops Manager will first create a local restore of a snapshot from the block store, and then it applies the stored oplogs until the specified point in time is reached. So, yeah, They will take longer than restoring from a snapshot, and that duration depends on the amount of changes, right? And then you get the restore files via the same HTTPS or SCP mechanism. So let me move this back to the demo. All right, so here, let's look at the restore for this sharded cluster. Right now, remember, I can expand this sharded cluster, and if necessary, if you want, I can take restore of an individual shard, but then you have to be careful about that. And if you have a balance, if you are running with your balancer on, then I don't know how useful that individual shard data is for if the intent is to actually restore that sharded cluster. So if the balancer is on, practically you would use restore at the sharded level. So to do the restore, you just click the restore button and then select various snapshots. This is just a database I created. I'm not doing anything on it, so it's not much interesting happening from a database perspective. But from for restore, I mean, I can select snapshots, or I can select a point in time. Now here, for example, my last snapshot, let's say I take something after 4:23, so I could select a date, 4:23, and give a time, let me say 6 a.m. in the morning or something, and see next. Then these are the available checkpoints that I had. Now in the sharded cluster here, I had set for 30-minute checkpoints, not the 15-minute ones. So these are the checkpoints that are available to you. I could select one and say next. At this time, I have the option of configuring my SCP info to SCP the files out to my destination, or just for the purpose of demo, I could use a pull using the secure HTTP. I'd finalize the request, at which point since I have set up two-factor authentication, it will ask me to input that info. Let me quickly get that. Here. Once I'm verified, I can finalize this request, and now the work of getting the snapshot before 6:26 and then applying any changes, which I don't have, happens, and then once that's done, your delivery method will be available. Now, as an administrator, I have configured my email address to this group, so I will get an email notification when it's ready, or I can, of course, look at the restore history and wait for these to finish. In fact, I see that the shards are already ready while the config is still being built, so I can monitor progress here. When I want to download, I can click on this download, get this link, which I can copy, and then at my terminal, or where I have to do it, I can do a call and pull these data out, right? I can do a download and copy to my local laptop if that's useful. But again, that's the method with the HTTPS pull request, right? I did not open the firewalls between AWS and here, so the other method, of course, could have been to push this via SCP. So that's the way you would restore. In case of a replica set, you can, of course, select a point in time, or you can select a specific oplog timestamp that's available to do that. So this is right now I don't have anything, so it doesn't matter because I don't have changes there. But the next point is, I mean, with replica set, you can go to specific points in time. With sharded cluster, you can go to specific checkpoints, and thus, depending on your RPO, you could set those checkpoints as low as 15 minutes. So that was a quick note on Restore. This slide is just state and obvious as an advice. Please test your Restore process, whether you do backup with backup manually or whether you use MMS or Ops Manager. You got to make sure that your Restore process is tested. If you cannot restore, you are not backed up, right? So maybe try it out periodically or sometime after making major changes, whatever fits your operational practices. But if there is no operational practice to test your restores, you need to have one. So in summary, I'd say you can meet your business objectives for availability. You can meet your RPO and RTO objectives with MongoDB. You can use replication, with which you can meet your availability requirements. You can protect against disaster by having replica sets, span geographies, and so on. You can use backup methods. In these, I'd say we will leave MMS and Ops Manager. That helps you a lot, especially if you need to do point-in-time restores. Even in cases where clusters are small and MongoDump is a good use case, if you have several of those, managing and monitoring that can be a bit of a problem, and that's where tools like these automated ones can come in handy. Now, if you plan to use Ops Manager, you can, of course, download and test for development or evaluation purposes. And if you have a large deployment or you want to manage multiple MongoDB clusters, you want to back up multiple MongoDB clusters, work with us. You can use our professional services to help with planning for your operations and backup needs. So that's one. I've included some links here you can refer to later. Last but not the least, I want to invite you to MongoDB World. It will be held in New York near the Times Square. Exciting place to be in. There will be many sessions that will be there covering different tracks. There will be business tracks, developer tracks, and there is an operations track too, where you can hear from our experts as well as from customers who are using us and our tools, learn from them. And you get to spend an evening at the American History of Natural Museum, right? So the website is mongodbworld.com, and you can use my code if you want to get 25% off. That's Toji George there. With that, I want to move to questions. We have a few minutes left. I also want to remind you before I start taking the questions that there will be a survey at the end. It will have some Q&A about the session, what's next, and we take your feedback and base our future sessions on that, so please do answer the survey questions. Now let me look at the questions here. So give me a minute. So somebody's asked, if we have a sharded cluster deployed on 3-member replica set deployed on 2 data centers, 2 and 1 hidden, what is the easiest way to restore cluster when active data center fails? Right. So the point here is you have chosen to do it that way. That means you will not be able to get an immediate availability if you fail over to the remote data center. You have to. You will need, I'd imagine, additional members at the remote site to be added to those replica sets so that you have a available system again at that remote data site before it can be available to the application. That's why in the multi-data center deployment that we showed, if you have requirement that your disaster or the secondary data site be available immediately, you need additional members there, right? So that it can map to the primary and maybe have a third data center to break the tie. If not, you're talking about standing up additional members so that you again have a replica set so that you can bring that back to your applications with confidence, right? By the way, that secondary there, it will still remain accessible, but it won't be able to elect any primary if you have this 2+1 scenario. Instead of MMS, is there a way using which I can take differential backup during the day via Oplog? We are taking full backup already. Well, I mean, not really. I mean, you can build tools around it. You can try to query the Oplog and do interesting things. When you do, let's say, something like a Mongo dump, well, if it's a sharded cluster, it's no use trying to do that from MongoS. But maybe if you are able to consistently take members offline, you might be able to do something. But again, it just becomes a little difficult. It's possible to do that. What we are doing essentially is we have built tools around being able to read the Oplog and do that. So they're talking about building that tool yourself, right? Is there a replacement for dbpath in version 3.0? I'm not sure I understand the question. There is a dbpath still in 3.0. The thing is, you still have to use dbpath and then to start the database, and that dbpath would point to wherever your data files are. I guess one difference you got to keep in mind in 3.0 is you cannot have same path for mmap as well as white tiger, so they will be different DB paths. If it so happens that you have existing DB path with mmap files, you need to have a different DB path to start. So that with white tiger. That's a short answer. I mean, this is not meant to be detailed about white tiger. Do you need to back up your binaries, not just your data? I think this question is in relation to the previous one about going back to older versions. They will be available to download, I'm pretty sure. But at the same time, I'd say if you are going today and maybe 3 years down the line, we have a version, and that version's output needs to be restored back to the version we have today. I can imagine a scenario where you may need to go through additional steps, downgrading multiple ways and so on to get to that version, or if you are able to get that backup and get the binary, it might just be easier for you. Does disabling the balancer stop the Mongoose from periodically taking on the task of the balancer? Well, if you are disabling the balancer, then the balancer is not happening, right? The splits will still happen, but balancing will not happen. So there is no balancing if you disable the balancer. By a standalone MongoDB, it means a single instance of MongoDB with no replica set or shard, correct? Let me break that down. So standalone, I do mean single instance of MongoDB without a replica set. Now, in theory, you can create a sharded cluster that has got multiple shards, but no replica set for each shard. But I'd say that's a less available configuration, right? So yeah, I mean, you have to have replica sets. And then I think the context of this question is that's how you get oplogs, and we use MMS, and Ops Manager would use oplogs to tail changes from. Does MMS backup capture the topology information as part of the backup? For example, how many shards, replica sets, replicas at the time of the backup? Okay, so earlier I mentioned about how each head would map to each replica set, whether that's a replica set or whether that's a replica set representing each shard. So we have one per primary. At the same time, the topology itself is something that would be not so much part of backup as it is part of the deployment view you may have via MMS, right? So the deployment view would show that, hey, I had all this with deployment. Maybe it's unavailable now, but you still have the metadata. So that would be your view to what the original deployment was. Remember, in the restore, all this is doing is making available the files to you. At that point, you may have to keep that to the different shards before you bring that back up. So yeah, I mean, that's the quick answer to that. I believe that's what you mean, but otherwise the only way is to know the topology you are looking at the MMS deployment or monitoring screen. So you can only do a point-in-time recovery to the timestamp of a particular snapshot. Some data will be lost in any recovery. Amount will depend on frequency of snapshot. No concept of up-to-second logging. We try to understand the question. So up to a timestamp of a particular, no, so maybe you cancel this question, but no, so snapshot is one, and then if it is a replica set, you can choose a point in time, at which point we'll take a snapshot, apply data from oplog to get to that point in time and give it back to you, right? So there is a concept of, we will recover up to the logs that we have, that when I say we, I mean MMS or Ops Manager has received. And of course, in case of sharded cluster, it will be dependent on that checkpoint. Could you use MMS backup with a replica set of 2 MongoDB instances? You can, yeah. It's just that in my mind, 2 is a reduced availability, because if one goes down, there is an availability aspect to it, because if one goes down, you do not have a quorum to create another primary. You could use an arbiter for that. No, but from a backup perspective, yeah, that's not a problem. Performance impact of checkpoint if very frequent intervals. So that was a question, and I think it means what's the performance? Okay, so so at checkpoint, what happens is the backup agents are inserting tokens. These are no-op tokens, very low impact into the op logs. But there is a thing, right? Before that, the balancer is getting stopped, and after that, the balancer is getting started. So really, the time it takes will be dependent on the workload you have running on those clusters. And I'd add that it doesn't try and impact the existing performance of the application. I mean, that impact is quite, nevertheless, balancer is being stopped and oplog token is being inserted, so that's happening. To test backups, would you recommend restoring to a separate replica set or cluster? At minimum, yeah. I mean, let's say you have a 5-member replica set, and you could try and take a backup and restore as a 2-member replica set or something like that, right? I mean, just to make sure that, yeah, the data comes up and you are actually able to create a replica set with it. In case of sharded clusters, it could be a little more difficult, but yeah, I mean, you need to test it separately. You would not restore it over the existing running production. And I'm sure that's not what you meant, but the point is you will have to restore it to a separate replica set. Can you set up MMS to automatically take periodic backups? I think you showed these point in time on right side panel. Okay. Well, it is taking backups continuously, right? This is a continuous backup, not a periodic backup, in the sense that data is continuously being read from your systems via oplog, and we keep that at our end. What's different is we periodically take snapshots and then maintain these replicas or maintain the oplogs also. So that way you can always go back to a specific snapshot, apply the changes, and then get data out for restore. How much does Ops Manager cost? I'd say just reach out to sales at MongoDB. Ops Manager itself is not sold as a standalone tool. It is something that's included with the Enterprise Advanced license. So the chat questions are done. I'm looking through the people on the web, and I see there is one hand raised. Not sure. So, Dana, is it possible to let people ask questions on the call, or do we?
I know it's not. They can only type in the questions.
Okay. So, Sanjay, you may have to type in your question if you have any. Oh, okay. Looks like the hand is down.
Right.
So, all right. So I think I answered the questions we have. Once again, thank you for attending this webcast. Please do answer the survey questions after this, and have a good day. Bye.